Greetings, Earthlings. Lesson 49 today, writing equations in slope-intercept form. Let's go briefly over the few things that you're going to need today. This is a pencil. You want that. Probably one with an eraser. You're going to need a notebook. Keep notes in today. Remember, you get to use this when you take a test, so definitely the more you write down, the better for yourself. And then today you're going to want to make sure that you've got some grid paper. I emailed this to you. There's 4 and there's 6 on those pages. And then you're going to want to have print off some homework paper so you can get that back to me and get credit for what you do. So let's talk about that word intercept. You've already dealt with the issue of slope before, or the steepness of a line that's graphed in what's called y equals mx plus b form. That is what we have today of slope-intercept form. Let me write that up there and we'll play around with that a little bit. That's just a form. They said that's if an equation comes with a y and an x, and then it has numbers in there. What do those numbers represent? Okay, so I think you've talked before about slope being the steepness of a line. And then over here we have this other number, b, and this is going to be our intercept. That's the intercept of slope-intercept form. And the question is, the intercept of what? Okay, now on our regular grids we have 2 axes. We have an x-axis and we have a y-axis. And in our equation, we have both x and y in there, and how they play with each other depends on what our picture looks like. So a line could be coming through here, and I'll just put one right here. And it crosses the y-axis right here, and it crosses the x-axis right there. Okay. The thing that we care about in slope-intercept form, the intercept, the part here that's lettered B, is going to be this one right here. Wherever the line crosses the y-axis, that's what the intercept is. So it's not really just any intercept, it's really a y-axis intercept. Anywhere along here where it crosses that axis. Okay, and what we're going to do with that point is we're going to call it 0, b. b representing whatever the number is for where that line crosses that axis. In this case, it would be -3 being your point. But in general, the number b is going to be wherever that line crosses the y-axis. Now, the reason why I put 0 is because that if I plug in 0 for x into the equation, the answer has to end up being b. Y will equal b. If I plug in a 0 right here, no matter what m is, m times 0 is going to equal 0, and y just equals b. So I'm always going to have that point 0 something is where it crosses the x-axis. Okay. Any 0 for x in the equation of a line is going to tell you where that's going to be. Now let's change that equation to something that looks more normal. Let's go with 3x minus 4. 3x minus 4. This is something that you could plug into this. You just turn it on, and you're going to go to that y equals, and you can enter in, oh boy, the shine is really bad, 3x minus 4, and hit graph. And you can see it for yourself. But if we look at that, and we plug in this case, a 0, then we'll get 0 minus 4, and y equals -4. That would mean that we would want to graph its intercept at 1, 2, 3, 4. Down here, -4. That's where this one will cross. I don't know exactly what the slope looks like yet, but as far as finding an intercept, there it is. It crosses at 0, -4. Okay, that negative 4 is just sitting right there in the equation. It tells you exactly where to put that point. Now we just need to know how steep that line is so we can draw the rest of it, and that's where the slope part comes in. Okay, so if you want to know the y-intercept, you just plug in a 0 right there, and the y comes out. Or you can just look at this part of the equation, y equals mx plus b, and there is your y-intercept. Okay, so let's go back to the form of these things. Y equals mx plus b. Okay, we've already talked about that part right there. What about this part right here? And we've seen that before. I think you've seen that before. That is the slope. Okay, this part here is the slope, or the steepness of the line. Bigger the number that gets, the steeper it'll be. Positive, or a bigger number, negative, it will slope down as we move. We read an equation the same way, or a graph, same way they would read a sentence. We read it from left to right. There's some notation and way that they talk about slope that I just don't like in math books. They talk about rise over run, and I think that's a horrible way to talk about it because you never remember which way you're going to is rising. But if you think of you're always going from left to right, that should help you make sense. So slope is that value, that letter m. And m is equal to a change in y over a change in x. I'm going to use that triangle there to represent change. Anytime you see that triangle, I'm going to say the word change. I want you to just get used to that. We're going to see that in geometry. The y change is going to be up or down. And so if the y change is up as we go from left to right, if the equation is going up, then that's a positive y. And if the y changes and it's here and then it's down here, that's a negative change. X always changes this way. There's no positive or negative change with the x. X always changes from left to right. In fact, I could almost just write it like this and just constantly just put a little arrow above it, so you know you always look at the change in x going across the page. Okay, that's very important for you to remember so that you don't see something go this way and you think, well, that's up. No, that's down because it goes from left to right. Okay, I'm going to pause this for just a second and get myself reoriented, and then we'll move on. Okay, ready. This is the form. This is the easiest way to do it. This is the way you can type it straight into your calculator and see the picture. But this is the way that these things come sometimes. Okay, now the trick is to move things around on this equation so that it looks like this equation, which basically means the y has to be on one side of that equal sign and everything else goes on the other. And you put the thing with the x first, and then you put the thing all by itself, the constant, it goes next. That way you can just read the equation and figure out where all the points need to go. So I'm going to do this really quickly, and again, you can always hit pause, and you can always go back and look at things again. But I'm going to keep moving because I need to keep this less than 15 minutes. Okay, so we're going to do to one side what we do to the other. I'm going to move this to the other side. Y plus 5 equals negative 2x. And then I'm going to subtract 5 from both sides so that y is now all by itself. And the rest of it is in the form that I need. So here's my intercept. 1, 2, 3, 4, negative 5. I'm going to put the dot right there. And then here's my slope. Okay, now negative 2 means that I'm going to go down 2 and over 1. Negative 2 is the same thing as writing it as negative 2 over 1. Okay, remember that over, we're going from left to right. So I would go down 2 places over 1, and that's enough for me to draw this picture. I just connect those dots and draw a line through them. and there I go. I've graphed that in that form. It has to be in that form first in order for me to graph this more simply. Okay? I don't really need to know this x-axis intercept yet, not for drawing it. I just need 2 points. I need to know where one point is, and that's the intercept. That's easy to find. It's right there in my equation. And then I'm going to use the slope to find another point and then draw that line. You can always verify by typing it straight into your calculator and then making sure that your picture that you drew looks like the picture on the calculator. All right, let me give you another one here really quickly. Show you that sometimes all the information doesn't seem to be there. So one of our examples is like this. Okay, so the question here is, what's b? There's no number over here, so what do we do with that? We're supposed to have both sets of information, but we only have one. We only have the slope is 2/3. We only have that the slope will go, this is a positive number, so we'll go up 2 and over 3. But from where? That's the question. So if ever there's just a big old blank there, it's as if we have an invisible 0 sitting there, and that's our intercept. If we plugged in a 0 right here, that'll be 0, and that's a 0, which means that we're going to put it where y equals 0, and that would be right there. Okay? From there, now we can go up 2 and over 3, up 2 and over 3. There's a second point, and then we play connect the dots, and we're done. So 2 points is enough to graph any equation. Okay, if you can get that equation into the right form, first of all, by just using the regular rules for doing unto one side what you do to the other, and get y all by itself on one side of that equal sign, you can then read the equation and immediately draw the picture. Use your calculator to verify what it ought to look like. Let me give you one more, and then you can look at your book for the application question about rental rates. This one is y equals 1/2 x minus 1. So this part right here is what I would do first, because I don't know where to draw this line until I have a point for it to go through. So I'm going to put that point right here at -1, and then I'm going to go up 1 because it's a positive 1, and I'm going to go over 2. So I'm going to go up 1, and I'm going to go over 2. There's my second point. I can then draw the line through those 2 points, and I'm done. The fourth example with rental rates takes one of these things and makes it applicable to real life. They assign a value, or they assign a characteristic to x, and they say, as x changes, how does y change? And in the example, the number of hours that you've rented something is going to be the variable. It's going to be x. And this thing comes up if you're going to go rent something, and sometimes there's like a mileage, and sometimes there's a flat fee kind of thing. So in this case, we have for every hour that you rent this thing, you're going to pay $10. But in order to rent it, you're automatically going to pay $25 for a flat fee. And then depending on how many miles or how many hours you have this thing, you'll pay an additional whatever. So the thing is to get the job done quickly. And that is an equation of something you can graph. You type that into your graphing calculator. And in order to see it, you're going to want to push the zoom button up here and which one is it? Zoom fit, which I guess is number 0. You're going to scroll down until you see zoom fit, and it will readjust the screen so you can see the picture so that you can draw it on your homework. That's it for that lesson. Make sure that you pay attention to the right questions that you're supposed to do, and remember you can always call up or email and get some help that way.